one of the benefits of defining limits in calculus before we even get to derivatives and integrals is that limits help us to make precise this idea of what it means for a function to be continuous. What's nice about continuous functions, among other things, is that they can't skip over any output values, right? If a continuous function goes from an output value of 6 down to an output value of -2, then it must have passed through the output value of 0 at some point, right? That's the intermediate value theorem from calculus. And so just as in single variable calculus, we can define a continuous multivariable function by the idea that the function, first of all, has to have a value at the point in question. It has to have a limit. The limit has to exist at that point in question, and that the value and the limit have to agree at that point. So continuity just means that the story that the function tells you at a certain point is the same as the story that's being told by the limit nearby that certain point. Right? The only difference is that now this limit is a multivariable limit. Right? It's a limit of a function of several variables in the sense that we've been talking about today. And so how we typically end up using continuity in multivariable calculus is to evaluate limits after we already know that a function is continuous. So once I know, or I have a reason to believe that a function of several variables is continuous, then if you ask me what is the limit as we approach a certain point, I don't have to worry that maybe a bunch of different approaches are going to give me different answers. If my function is continuous, that means its limits all exist. And not only that, the limits are equal to the value of the function. So if I wanted to find the limit of, say, this polynomial function, if I know that it's continuous, if I want to take the limit as we approach, I don't know, 2, 6, then all I have to do is plug in 2 for x and 6 for y and get the value of the function, because for continuous functions, the value and the limit are the same thing. And so just as in single variable calculus, limits have arithmetic properties associated with them. So the limit of a sum of functions is the same as the sum of the limits. The limit of a product of functions is the same as the product of limits, quotient, scalar multiples, all of that stuff, that as long as the limits on the right-hand side exist, then they are equal to the limits on the left-hand side. And so the multivariable function limits enjoy all the same properties, and so therefore do continuous functions of several variables also satisfy these arithmetic properties, that the sum of continuous functions is continuous, so is any multiple, the product, the quotient, as long as the denominator is not 0.